All right, let's get right into it. We are taking a deep dive into what might be the single most important test flight in SpaceX's Starship program so far. This isn't just another launch, you guys. This is basically the final exam.
So go ahead and mark your calendars. On this day, the Beast is scheduled to lift off from Starbase, Texas. And look, the stakes really couldn't be any higher. This whole flight is designed to prove that the core technologies behind the whole Starship idea actually work.
And that brings us to the big question we're going to answer here. For Starship to truly succeed, to graduate and move on to the next big thing, it has to absolutely nail two incredibly difficult tests. So let's break down exactly what they are. But first, just a super quick refresher in case you're new to this. When we say Starship, we're talking about the whole thing. That giant booster on the bottom, that's super heavy. The spacecraft sitting on top is the ship. You put them together, and what you get is the tallest, most powerful rocket ever built, one that's designed from day one to be totally reusable. Okay, let's get into that first critical test, the super heavy booster's landing burn. Now, the end game here, the big dream, is to catch this thing, which is literally the size of a skyscraper, with giant robot arms on the launch tower. But before you can even think about doing that, you've got to prove you can bring it to a gentle, super precise hover just over the water. And that brings up the key technical challenge for the booster on this mission. You see, past flights used fewer engines for that final landing part, so why is a 5-engine burn suddenly the main event? What's the big deal? Well, this is where it gets really interesting, because you can see the logic right here. With fewer engines, you just have less steering power, right? And your safety margin is way smaller. But with 5 engines firing, suddenly you get incredible precision. You get what's called engine out tolerance, which means if one engine quits, the others can pick up the slack. And you can control how fast you're coming down with way more finesse. It's more complex, for sure, but it's a trade-off for the kind of safety and reusability they're aiming for. So the key takeaway here is that this is a full-on dress rehearsal. The goal isn't to actually catch the booster yet. The goal is to achieve what they call a catch-grade descent. They need to prove they can nail the ignition timing, handle all that complex steering, the thrust vectoring, and smoothly manage the engines, all leading to a nice, controlled splashdown in the Gulf. Every single piece of data they get here is what makes that first tower catch attempt even possible. Now, let's shift gears to the second big test. Because while the booster is doing its whole landing dance, the ship, the upper stage, is screaming through its own trajectory, facing a totally different and frankly terrifying challenge, surviving a fiery gauntlet as it comes back through the atmosphere. And just to give you an idea of what that gauntlet means, look at this number. Over 3,000 degrees Fahrenheit. The heat shield, with its thousands of black tiles, has to survive temperatures hotter than lava as it plows back into the air, literally turning the atmosphere around it into plasma. It's just insane. And the ship has its own crazy checklist to get through. It's not just about surviving the heat. It's about being in control. Can it actually use its flaps to bank and steer while it's wrapped in plasma? Then, out in the freezing vacuum of space, can it relight an engine? That's a make-or-break moment for pretty much any real mission. And on top of all that, they're even going to test the payload door, practicing a satellite deployment. Every single one of these is a massive hurdle. And, this isn't just some internal SpaceX test for its own sake. Every single one of those green check marks is directly tied to NASA's Artemis program, the lander that's going to put astronauts back on the moon. It's a version of Starship. So NASA needs to see those reliable engine relights, that precise guidance, everything. A win for Flight 11 is a huge step forward for getting boots back on the moon. So with these two huge tests in mind, let's kind of zoom out and talk about the verdict. What does success actually look like for a test flight? Because it's not as simple as just did it blow up or not. For SpaceX, it is all about getting the data that paves the way for rapid, full reusability. And this table here explains their philosophy perfectly. A full success is awesome, a clean run, they nail all the objectives, and they get the green light to move on. But a partial win, let's say an engine fails during landing but the booster still makes a soft splashdown, or the ship loses a few tiles but survives, that is still incredibly valuable. It proves their backup systems work and gives them priceless data. For test flights, the data is the real prize. And that really gets to the heart of why this flight is such a big deal. It is truly the final exam for this entire generation of prototypes, the version 2 Starship. It's the culmination of everything they've learned from all the previous flights, designed to prove this design is solid before they move on. This timeline really puts it all in perspective. The first flights were just about learning to fly, not blowing up on the launch pad.
The more recent tests have been about checking boxes on key systems, like hot staging and surviving reentry. Flight 11 is the capstone. It's the final exam. If it goes well, SpaceX can confidently shift its focus to version 3, the next evolution that's supposed to deliver on that wild promise of an airline to orbit.
Which brings us to the final, and let's be honest, most exciting question. Every successful test, every bite of data they get from that booster landing and that ship's fiery return, it's all another step towards that ultimate goal. So, with the data from this flight, you have to wonder, just how much closer will we be to turning the world's most powerful rocket into a true airline to orbit?